This page of notes is just really an extra to kind of help you have an overview and help you master your factoring. Some questions you should always ask yourself after learning all of those different types of factoring methods are listed right here. The first thing we should do is ask ourselves, is there a GCF? The next thing I would do, even though it was the last thing we learned, was, is there a pattern, a perfect square or a perfect cube? And then if you say no to those, or maybe you pulled a GCF out and there wasn't a pattern, then you need to go look and see, does the first term have a coefficient? No, then you can just do the product sum method. If it does, then you would have to slide and divide. So that kind of helps you understand the process that you should maybe be going through when you're factoring. So looking at number 1, is there a GCF? No. Is there a pattern? Are my first terms and last terms perfect squares? Actually, they are in this one. So we can try that pattern. Sometimes it works and sometimes it doesn't. X times X is X squared, and 6 times 6 is 36. My middle term is negative, so I could maybe use 2 negatives. If I factor it that way, would I get that middle term of negative 12x? So this would be a negative 6x for my middle term and a negative 6x. So actually I do. So while product sum isn't very long and fast, you could have listed all those factors. And then you would have noticed you were using the same terms. You're going to get the same thing, but it just kind of helps you sometimes factor just a bit quicker. Looking at number 2, there's not a GCF, asking ourselves these questions. Is there a pattern? Do we have perfect squares? No, 14 is not a perfect square. So then we would ask ourselves, does the first term have a coefficient? No, it doesn't. So we could do our product sum method. Since our last term is negative, I know I'm using opposite signs. So I don't list that in the steps, but those are going on with the product sum method steps. Paying attention to that. If I take 2 times 7, I could get 14. If I had a negative 2 and a positive 7, I would get positive 5. So we have x minus 2 and x plus 7. And I'm not going to be as detailed as my normal lecture videos. This is just an overview to kind of help you with the steps that you should do when factoring. Looking at number 3, is there a GCF? No. Is there a pattern? Are these perfect squares? Yes, remember a difference of 2 squares would have a minus sign between it, so we actually could factor this. We could set up our 2 parentheses and say 5x times 5x would make that 5x squared, and 1 times 1 would make that 1. And you always use opposite signs when your last term's negative, also with that pattern. That's what we learned. And you could go through and see how your middle and outer would cancel out when you multiplied them. Number 4, there is not a GCF. And unfortunately, there is not a pattern. There's nothing times itself that makes 5, nothing times itself makes 3. So since there's a coefficient, we have to slide and divide. So 5 times that negative 3. So I have x squared minus 2x minus 15. So we make that temporary polynomial. Then we can look at 15 and list the factors of 15 to find the negative 2. 3 times 5 is 15. If I had a positive 3 and a negative 5, that would make the negative 2. So remember, you set up your parentheses and we'd write x plus 3 because it's a positive 3 and x minus 5 because it's a negative 5. So remember, we slid that 5 to the back and we factored that temporary polynomial. So we need to put the 5 back in for the divide step. So you would write divide by 5. So since 5 can't go into 3 evenly, we slide 5 up to the top. So 5x plus 3 times x minus 1. Again, you can check yourself. Front times front, first times first, 5x squared. 3 times negative 1 is a negative 3. Your middle term comes from the multiplication of your inner, 3x, and outer, negative 5x, which would make that negative 2. Looking at number 5, there's not a GCF in 49 and 36. I notice it's 2 terms, so I'd probably always check and see if it's a difference of 2 squares. Are they perfect square numbers? That's where the pattern comes from. Yes, it is. So just like in number 3, we could say 7y times itself would make 49y squared. 6 times 6 makes 36, and use opposite signs. And so if you notice those patterns, notice how much quicker that goes than having to slide and divide and find 2 of the same numbers. That's going to cancel out so you don't get a middle term. Number 6 does have a GCF, so we could pull out the number 5. So be sure you do that before you try to jump into sliding and dividing, you know. That would be very important. Otherwise, you'd get the wrong factoring. So while five of these so far haven't had a GCF, number 6 does. So we would be left with 5 goes into 5 one time, so y squared, plus 5 goes into 10 two times, plus 5 goes into 5 one whole time. Then we'd look to see if we could factor this further. So we have 5, and I'm going to open my 2 parentheses. Since there's not a number in front of my y squared, I could think product sum, or really this is actually a difference of 2 squares. They're just really small, right? Y times itself makes y squared. 1 times itself makes 1. And if I use 2 plus signs, we could add those ones together, even if we thought of that as product sum method, to make the 2, right? So we're done. And remember, I always write perfect square trinomials out twice. Could you write it as 1 parenthesis squared? Absolutely. I just go ahead and write it out twice, and I think it's an okay habit to continue. Okay.